Happy day, everyone. This is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Please do not forget to like, share, subscribe, and click on the notification button to have more of my video. For partnership, this is my mobile line, and this is my OPEC account for sponsorship of this video. Thank you so much. Today, we are taking a topic in mathematics, and that topic is on calculus. And then the aspect of the calculus we want to take is differentiation from the first principle. There is a particular function that is common, in simple calculations, and that function of x is given as f of x is equal to ax raised to power n. That's what I have here. So let me make my f of x to be y, which is a raised to power ax raised to power n. We want to find the y, the x, which is written as y prime, from the first principle. So these are the steps. Please, this particular aspect is a common question in 100 level in some institution, and also take note of it. I'm talking about the final year students in secondary school. Take note of this principle. Now, what we are going to do, let me write the y is equal to ax raised to power n. Let me write it out. When there is a little change in x, there will be a change in y. So what am I trying to say is this: then this x, let's say there is a little change in x, call that change in x as delta x, then raised to power n. Then what I'm going to have, I will have a change in dependent variable y, which is y plus delta y. So the next thing we are going to do, before I go further, what we are trying to arrive at is to get an expression delta y divided by delta x, finding that limit as delta x tends to 0. We say is the y, the x. This is what expression I want to derive from what I have here. Now, making this delta y subject to formula, I have delta y is equal to ax plus delta x raised to power n minus y, and my y is ax raised to power n, so I substitute it here. Now, look at this place now. Delta y will now be equal to a brackets x plus delta x raised to power n minus this ax raised to power n. Now, you remember binomial expansion that I did the other time. So I will want to do binomial expansion for x plus delta x raised to power n. Let me do it here. X plus delta x raised to power n. I said it can be written as summation from r is equal to 0 to n. Then my combination starts from r to n. Then we multiply these terms together. That's why we call divide simply means 2. So we have x. That's the formula for the expansion. Take note of this formula. X, that is times delta x. Then this x will be raised to power this total power n, and then I'll write x raised to power n minus this r, then with this second term raised to power r. So this is a summation sign, meaning that the counting starts from 0. So I can have this as a combination 0 to r, then x raised to power, when my r is 0, that is n minus 0 delta x raised to power 0. Then I'm going to add it plus r combination 1 x raised to power, sorry, I'm going to have from 0 to n, 0 to n for the combination. So n combination 1, then I have n minus 1, then delta x raised to power 1. Then I'm going to be having this particular expression up to n. So I have n up to n combination n. Then I have x raised to power n minus n, then delta x raised to power n. That is the expansion of this particular expression that I have here. Now, the next thing is this: n combination 0 is the same thing as n factorial divided by n minus 0 factorial 0 factorial. Then n minus 0 is n. So I'm going to have x raised to power n. Then delta x raised to power 0 is 1. So I've gotten the expression for this one to be this. Then plus this expression here, it means n factorial divided by n minus 1 factorial, then times 1 factorial. I've gotten an expression for this, then times x raised to power n minus 1, then delta x. Then this particular addition will continue up to n combination n. N combination n is n factorial all over n minus n factorial multiplying this n minus n will be this power here will be x raised to power 0, then times delta x raised to power n. So I can, this expression I'm doing here is for this one alone. Take note of that. I'm not through with this expression. That's what I'm having here. Now, if you look at this place here, n minus 0 factorial is n factorial. N factorial cancel n factorial. And 0 factorial is 1. So everything here will be 1. So that means the coefficient, the Pascal coefficient here is 1. So I'm having x raised to power n, then plus, if you look at this one now, I can rewrite it so that I can be able to cancel this one that is here. So this n factorial, I can rewrite it as n times n minus 1 factorial, then divided by n minus 1 factorial 1 factorial times x raised to power n minus 1 delta x, then plus here n minus n factorial is 0 factorial. So 0 factorial is 1. So I'm having 1 times n factorial. Cancel this n factorial. The whole of this place will become 1. Then anything raised to power 0 is also 1. So I'm left with a delta x raised to power n. Now, if you look at this place, this delta n factorial minus this cancel this one that is down. So I'm left with a nx raised to power n minus 1 delta x. So what I'm going to do now, I need to create a space here for us to see what is actually happening. So here now, I will now write my delta y as a times everything that I just obtained for x plus delta x raised to power n, which is what I have here. So this a times everything, and everything I have here is what I have down. So times x raised to power n plus n x raised to power n minus 1. Then I have a delta x. Then, you know, this place is supposed to be dot dot dots, up to dot dot dots. We are going to add it. So I'm going to say plus dot 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 plus delta x raised to power n. Then minus what I have here, ax raised to power n. Ax raised to power n. So take note of that. So I will use this a now to open this bracket. I'm going to have delta y is equal to a bracket, okay, a times x raised to power n will give us ax raised to power n plus an x raised to power n minus 1 delta x plus dot 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 plus a delta x raised to power n minus this one now, ax raised to power n. If you look at this term here and this term, they cancel out. So let me create a space. So what I have here now, this term and this term, they cancel out. So I'm left with delta y is equal to an x raised to power n minus 1 delta x plus dot 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 a delta x raised to power n. So what I'm going to do now is to divide both sides by delta x. So I'm going to have delta y divided by delta x is equal to an x raised to power minus 1 delta x divided by delta x plus dot 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 plus, I'm supposed to have plus there, then dot dot a delta x raised to power n divided by delta x. Delta x cancel delta x here. So I have delta y divided by delta x is equal to an x raised to power, this is n minus 1, then plus dot 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 plus dot dot a delta x. From the law of indices, I can put this one in a single form. So it's going to be raised to power n minus 1. Now, the limit of delta y divided by delta x as delta x tends to 0 is called dy dx. Since this delta x tends to 0, everything here becomes 0. So we are left with this particular term. So I'm having an x raised to power n minus 1. So that is the derivative we are looking for. So that means the derivative of y is equal to ax raised to power n has been derived as a dy dx is equal to an x raised to power n minus 1. So that's the fundamental idea as to why we are subtracting 1 from the power of the function that we are given. Like for instance, if you are given a function like y is equal to x raised to power 3 minus 2 x raised to power 2 plus x minus 4, and you are asked to find y prime. The meaning of y prime means dy dx. So in this case now, we are going to use this particular formula that we have here to be able to generate the derivative that we are being asked to find. So what do we do in this case is to use this formula that we have here on each of these terms that we have in this equation. So I will say the y of this y, the x, is the same thing as the x of x cubed minus the x of 2x squared, then plus the x of this x, then minus the x of 4. So that means you are going to use this operator on each of these. What do we do? When you have this power, use the power to multiply. That's to get the y dx. Use this power to multiply. You have this. Then you subtract 1. So you use this power now to multiply. So this one become 3x. Then subtract 1. 3 minus 1. Then you say minus. Use this power to multiply. That is 2 times 2. X raised to power. Subtract 1. 2 minus 1. Then plus The f dx will give us 1. So write this one as 1. Then minus the differentiation of a constant related to a constant is 0. I'll prove it in my other video that time. So that means the y dx is given as 3x. This power 3 minus 1 will give us 2. Minus 2 times 2 we have 4. X raised to the power 2 minus 1, that is 1 plus 1. So the y dx can now be finally written as 3x squared minus 4x plus 1. If you are asked to find that derivative of this function, find this derivative. When you are asked to find this derivative, ask when x is equal to 0. So that means at a point when the value of the independent variable is equal to 0, we just write the y dx at x is equal to 0 become 3 bracket 0 square, you substitute 0 anywhere you see x, minus 4 bracket 0, then plus 1. Everything here becomes 0. 0 times anything is 0. So we are left with 1. Thank you so much. I believe that you have been able to learn one or two things concerning how to find a particular standard functions, the derivative of it from the first principle. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Please do not forget to like, share, subscribe, and click on notification button to have more of my video. For sponsorship, this is my OPay account 81413645573, and my phone number is 08141364573. Thank you so much. Have a nice day. Bye.